Right here, I'm just showing you the y-axis works just fine. I at first think that the z-axis is working fine, but the problem is if you go all the way past its limit point on the LCD screen, you can't go back. You can't get it to go back down. So if, let's just say the limit is 100. If you go past 100 on the LCD screen and the control knob, you can't go backwards to bring it back down. It's just going to keep going up and going up and going up, and it doesn't have a end stop on the top, so it's just going to get stuck on those nuts at the very top of those black rods for the z-axis, and it's just going to burn out the engine since there's no end stop up there. Now, if I try to go back, it doesn't want to work, so I have to hit the cancel button and go back, start over on the z-axis, and then I can bring it back down and return. Now right here what I'm doing is I'm showing you that the x-axis isn't working right. You can see that I'm turning the motor and it's just barely budging. I'm turning the knob on the LCD screen the same way that I did with the y-axis and the z-axis, but it's just not budging. It's not doing anything. It's not going back and forth, and it makes really strange noise. I can show you right here that the belt isn't slipping in any way. It's not too loose. It's not too tight. The belt isn't slipping whatsoever. And occasionally you can get it to go back and forth, but it's real spotty. It's not consistent whatsoever. So I thought that it was the x-axis motor that was the issue, but here in a minute we'll find out that it's not the motor. Or at least I can't tell if it's the motor, because I am fairly certain now that it is the control board. Because it also seems like the z-axis is having an issue as well. I mean, I build custom computers for work, and I have my own business doing that. And parts can be dead on arrival all the time. I'm very used to handling electronics and motherboards and RAM and stuff like that, so I know to take the proper measures whenever I'm putting these things together, you know, to stay very apparent of static. Don't want to have any static mess with the boards or anything like that. Clean surface, you get the idea. Right now what I'm doing is I'm gonna go to the x-axis again, and you can see very clearly that I'm turning the knob. You can see the dial turning. It's a little blurry there, a little glare from the window, but you can see the degrees that I'm trying to turn, and it doesn't want to do anything. It doesn't want to respond. So that's originally why I thought that it was the motor. So what I'm going to do now is I'm going to speed up the video and, you know, go through the connectors on the control panel, and I'm going to switch the X motor and the Y motor, and I'm going to do the same test. So I'm testing the Y, which is actually moving the X, and it's acting the exact same way. So that eliminates the motor at first. So essentially it's a process of elimination. So now it looks like I have a bad control board rather than a bad motor, because now the Y motor is acting, or the Y motor is acting the same way, and now the X motor is doing things properly. So